proportion things is to start with an example of a proportion that you guys know is true. 3/4 is the simplified version of 6/8. Because if you take 6/8, cut it in half, you get 3/4. You okay with that? So we would say that those two are equal ratios. When ratios are equal to each other, they create what's called a proportion. If things are proportional, that means that you can multiply the diagonals and get a true result. So if I do that, I can say that 3 times 8 is the same thing as 4 times 6. That holds true. Everybody okay with that? Now, all we're doing there is just, anytime we have fraction equal fraction, if it's true, you can cross multiply. All right? Some of the really basic properties of proportions then allow you to do other things. For example, if I take the 6 and the 4, and I flip-flop them on that diagonal, is that a true statement? Because what's 3/6? And what's 4/8? And I still have the same diagonal. 4 times 6 is 24, and 3 times 8 is 24. So I can exchange them, I can flip them diagonally. It means that I can also do this. I can flip them going the other way. I can flip them on the other diagonal. I can exchange those two. Now what I've done here, if you look at it, 8/6, divide those both by 2, you get 4/8. Convenient. Isn't 8/6 and 4/3 the flipped version of what we started with? Do you guys remember in Algebra 1 when you did exponent stuff like this? When you had same base, different exponents, and you were multiplying, what did you do to the exponents? Do you remember? Add them. Very good. So you had x to the 5th. Now, what happened when you had a negative exponent?
You had to bring it down the fraction, right?
Correct. This wasn't happy. Wasn't happy in the numerator, so it was 1 over that. And what happens if it was 1 over to a negative exponent? You bring it up. Good. So it becomes positive. That's how you get these negative exponents. Now, whenever you use this thing called a negative exponent, it's called an inverse. Not so much important right yet, but if you look at what we started with, was it 3/4 and 6/8? If we use what's called the inverse, that means I would have to take the 3/4, flip it. Because remember, one of the properties was to send that to both pieces. Remember how he just flips the whole thing right away? That's why this kind of stuff works, because in proportions, you can do these kind of things. Okay? It's a little bit of, I'm just trying to show you guys a little bit of where you've come from before, when you learned about these exponent rules. A lot of this stems into reasons proportions work because of rules of exponents, by taking inverses, by flipping the fractions. These things still hold true. In Algebra 2, we actually have a pretty large unit all about inverse relations. How you do inverse functions, how you solve for them, how do you talk about domains and ranges. Stuff you'll do next year. In Algebra 2, we do a whole big thing about exponents again. Both positive exponents, negative exponents, and fractional exponents. It's all stuff that you guys will do again next year. It's all stuff that you've talked about before. But what'll change it'll be 1/2 plus 1/3, which obviously won't equal 5, but you'll have to get common denominators, things like that, okay? Each year in math, you're building off of things that you've learned in the past, just taking those extra steps. Another property. Watch what happens here. What did I do between those two steps? What did I do from the original on the second one? I what? You said it. I add the bottom to the top. I added the value of the denominator to the numerator. I added the bottom to the top, and I did that to both sides. Now, what's 3 plus 4? And 6 and 8? Aren't those equivalent? Isn't 7 over 4 half of 14 over 8? Okay. That's the idea of how these properties work. By keeping these things, I wouldn't say balanced, but you're using different ways to represent proportions, okay? Just by moving some of the values around. Now, what we're going to look at today, in terms of geometry-wise, is can you identify what they did from an example? Just like when we did fill-in-the-blank proofs, when we had the fill-in-the-blank proof stuff, we always try to figure out, well, they did this step, but why do they do this step? This is kind of the same thing to start with. For example, if I give you this, can I go to a clean one? I don't know if we're all caught up. If I go to a clean one here. If I look at that top one, if I look at that top one, it says 6 over x is 5 over y. That was your starting point. The second one then says, well, 6 over 5 has to equal what over what? What did they do? They moved to 5, so where did the x go? So what's underneath the x then? So if 6 over x is 5 over y, then 6 over 5 is? That's all it is. They exchanged it on the diagonal. It's the idea of being able to pick up on different ways to solve these types of, we're not solving for x or y yet. We haven't gotten there yet, but what we're going to be able to do is take these properties and then eventually be able to solve for x when it's in any one of those 4 positions. That's the main reason why we talk about this today. Hey, cheese. Taking a picture of yourself? Same deal here. What did they do between the first and the second step? Oh, excuse me. What did they do? They had the bottom to the top, so what's the second one gonna be? That's all it is. The first one they added bottom to the top, so it means the second one they have to add the bottom to the top. Whew. I know. Hold your applause. It's a lot. What'd they do there? Do you have to show that you did that? Could you figure out that that's what they did? So if the numerator changes but the denominator doesn't, what's 9 plus 2? Okay, so what's the other one going to have to be? X plus y over y. That's all it is. What do you mean, what?
Right.
So you started here, and you went to here. How'd you turn the 9 into an 11?
You added the top two.
Okay? So if I added 2 to the top here, what do I need to add to the top on the second one? Why? That's it. You're overthinking it. You're overthinking it. Watch this. If you have 4/5 and you have that equals 8/10, I just doubled it, okay? Now, if I add the bottom to the top, you get 4 plus 5 over 5. Add the bottom to the top, you get 10 plus 8, or you're right the other way around, 8 plus 10 over 10. What's 4 and 5? 8 and 10? That's all you're doing, but not showing that step. That's it. You're just not showing it. They're trying to get you to think that's what happened just by reading. You're trying to decipher what happened. I'm trying to figure out what happened. What happened? What? What happened?
No, I don't, like, seriously. Oh, I know.
You tell me. You tell me what happened. All right. Hey, is this true or false? Figure this out.
Thor, you can't explain.
I don't know what's going to know you. They can laugh.
They switched these to this lower down, and no one knows their names. I was doing it because
Sorry. Yeah, she's trying to. Oh, the hair throw. It's the international sign for I'm really trying. Oh, sorry. I didn't know that you needed 2 desks. That won't work. Yeah, that won't work. I told her that last year too. That's probably why I didn't say it. That won't work. Because what happens, that one does a lot of this stuff backwards. I'll show you. That's the old version of it. It still does, it does a fraction of it. That's not good. But what happens is if you take it still doesn't do it. It's the old version. Laptop's next to her. Short has a beard.
I didn't know you guys studied there.
Yeah, he's going to be 10 years younger, so you're awesome. Sure, why not? Hey, es verde or es falso?
What?
No, verde's green. I said it's green or false. Sorry. Lo siento. Okay. Sorry. Faraday's a lot funnier if you would have just rolled with me on this one. C as Faraday. Don't roll your eyes at me. I'm allowed to make a mistake.
No, wait, that's right. Green would be good, it's like, the color green is there, so like, go. Green. Yeah. Red. Yeah, you're gonna say it's also Christmas.
Yes.
I was trying to make you not sound.
Thanks. As terrible as I am.
Yeah, we know.
It's okay. It's been a few years since I've been in a Clase de Español. Is that true or false?
True. Wait. Yeah, true.
What do they do?
They switch the spots.
They just flip-flop the diagonal.
Yeah.
What about the second one?
That says no.
I have no idea.
Yeah, I didn't know what they did. Like, they said 2 Y, but Y is only 1. Like,
Well, all right. Let's think of this.
like,
So what they did was,
oh, wait.
what they did was they added the y value twice.
It's true.
Here they added the 3 value twice. Now, if we're not sure if something's going to be a true or false, remember how we did this before when we were trying to figure out a counterexample? Thank you for, oh. So, think of a really easy counterexample. Go back to 3/4 and 6/8. If this is going to be true, then I'd have to say 3 plus 8 over 4 is 6 plus 16 over 8. What I did is I added 4 twice, added 8 twice. 3 and 8 is how much? 12. What? Oh, I said 12? And 6 and 16 is how much? Isn't that true? Think about it. What they did here was this. What's 3 and 4? 7. We have 7 over 4 and 14 over 8. All they did was that property of adding the denominator twice. And it still works. Yes, ma'am? The 16? Okay. What I was trying to do was work off of this. I came up with just thinking of a counterexample. 3/4, 6/8. Ladies and gentlemen, come on. What I did here was that I did the 3 plus 4 plus 4. That's where I got 8. 6 plus 8 plus 8. That's where I got 16. I was trying to do it twice because it said, hey, will it work? Well, if I did it this way, it actually did work with 22 over 8 and 11/4. And I did it if I showed it the other way, this is if I do it once, and if I do it again, I'm going to get 11 over 4. If I add 8 to that, I get 22 over 8. So it's just showing that, yes, this case, it does work to do it twice. Okay? So if you're not exactly sure, always try to pick a couple of numbers, see if you can make it work. Okay? That's the idea. You're trying to see if it can work. You can try it again with 1/2 and 2/4. It should work as well. Okay? That's all. Now, what all this stuff is going to allow us to be able to do is work into stuff that looks like this then. Oh, I know. There's a proportionality statement of a triangle with given side lengths. Find the missing value. So what I want you guys to think about here is that, of course, over the course of the next day or so, we're going to be given information. We're going to be given your proportionality statement, especially today. You're not going to have to be able to figure it out yet. Eventually, you will be able to come up with your own ways of writing out your proportions. We don't know how to do that yet, but it only takes a day or so. We're only about a day or so away from getting there. Now, what I want you to think of here, since they're giving you information, all it is, substitute in. What's AB in the diagram? What's BC? We don't know. What's AE? And what's ED? 4. Cross, multiply, and solve. That's it. It's telling you what it is. You have to fill in the blanks. Whereas yesterday, you were given this part to start with. Today, I know, you have to read a diagram. It's a lot to ask. Cross multiply, we get 12x. It's 24. X is 2. And remember, you can always go back and substitute in to check and see if it worked. 2 times 12 is 24. 6 times 4 is 24. You know that proportion holds true. You know that your value of x works. Okay? That's where we're headed towards. We're heading towards getting information from a diagram and filling in the blanks. Okay? That was a sarcastic thumbs up, I think. Let's try another one. Same deal. Same exact deal. You're going to start with given information off of a triangle. We have the large triangle of ACD, and then you have a segment connecting the sides of the triangle at BE. We don't know if it's a mid-segment. We don't know where it's at. We don't know if it's parallel. We don't know any of that, but we just have that value there. From here, then, it's a matter of filling in blanks. They're telling you, hey, AB over BC is AE over ED. When you fill in the blanks of this, what's AB? 12. BC is I don't know. AE is 18. But what's ED then? 15. See how they added that one extra step for you? They gave you the whole segment, figure out the other part. It looks suspiciously a lot like segment addition stuff that we've done. Cross multiply, exactly. When you cross multiply out, you get 18x is 180. What's 180 divided by 18? Remember, I got 15. This whole thing here was given to you at 33. Subtract out the chunk of 18 and you're left with 15. Thanks, man. Watch your phone fall off. Okay? That's it. Those are heavy. So the pencils are heavy.
Oh.
Does it change when you get to having to use algebra? No. It's the next natural step within these problems. Again, you're going to be given some statement to work with. We know we have BD over DA, BE over EC. It tells you that. Sorry, that diagram didn't show up as clearly as I thought. Now, in this case, you're given the whole segment of BA is X. One small chunk of it, DA, is 3. So you have to figure out how do you find that other segment. So if from here to the computer is 12 feet, I go 3 feet, how much is left? 9, what'd you do? You did 12 minus 3. If from here to the door is 6 feet, I go X amount of feet, how much is left? If from here to the computer is 12 feet, I go 3, how much more do I have to go? 9. 12 minus 3 is 9. I've got 9 feet left. From here to the door is X amount of feet. I go 3 feet, how much is left? X minus 3. If the whole chunk of a segment is unknown, but you know a part of it, from this much of it is 3, how much is left between here and here? X minus the 3.
It's about this.
Remember, this is nothing more than segment addition stuff. It's a matter of looking at a diagram and figuring out what your values are. This is nothing new. They're just putting it into a triangle. Okay? So if you go back, BD, well, if the whole thing is X, this chunk from here to here is 3, what's left for here? That's all it is. And BE was 18 over 6. So you have this now to solve. There's a couple of ways of going about to do it. One of the ways is to notice right away that 18 divided by 6 is how much? 3. I could simplify that first if I want and say the following. X minus 3 over 3 is 3. Or I can cross multiply and do 6 times x minus 3 is 3 times 18. It still works. That way it's a little bit easier. Because how do you undo dividing by 3? Let's multiply both sides by 3 then. You get that. If I do it the other way, I have 6x minus 18 equals, what is that, 54? And I still get the same result. Add 18. What's 9 and 3? You get the same thing. Sometimes it's just easier if you recognize anything that can be simplified. Do it first. It's just easier on your brain. That's all. That's all that is. So quite honestly, that's about as complicated as we start with on these types of problems. We try to build out of this because you're going to be given things to be set up and set equal to each other. When we start it tomorrow about figuring out how do you use similarity statements and how do you create your own, that's when you'll have to do just a little bit more work. But then it's a matter of solving it like this. So we start with the real basic stuff. Simplifying fractions, solving for x, substituting, solving for x. Tomorrow we will similarity statement, write it out, solve for x. We're just adding one step at a time, okay? Any real crazy questions on that? Hooray. So I'll skip the other example because I'll make you do it.
What?
Do those, please. Okay. It's already linked up in the book and whatnot. Sir. Let me go.
Could you do 18 times 3 and then 54 divided by 6 and then add 9 and then add up 9 plus 3?
Yeah. Yeah, because that's all this is. You could have gotten from here.
I died.
A lot of times people get to here and just divide it by 6. and then this becomes a 3 right off the bat. So yeah, there's a bunch of ways of going about it. So yeah, guys, remember, there's a bunch of different ways to set these things up.